very much for being here. My name is Gavidia-Calderon, and I'm a research software engineer at the I've been created on April 2023, and since October 2023, I've been working with theories, trusted research environments, with one with another. The theories are these little cards, like the one featured in the flag, where researchers I meant to be able to work safely with sensitive data. And in this talk, I will tell you a bit about my experience with theories. This is done more with Camila Rangel, also from the talk. Okay, let me tell you a bit of what this is about. I will start talking about what theories are, why do we need them, and after that I'll move to talking about the promises and the perils. And the promises I have made some advantages of using theories. By perils I have made some risk of adopting them. And I will also tell you a bit about how do we in the Turing mitigate these risks. And I'll end with some final words about your. So let's start. I've been working with theories in the Turing because, well, I've been lucky enough to have worked with some sensitive data sets as an RC. I have used some transactional data from banks. I have used some patient data from NHS. And when you work with sensitive data, this data, especially because it's protected by law and for a good reason. If you talk about health, this data can contain which people have HIV, if people have drug overdoses, or if people have abortions. So you don't want this data to be disclosed accidentally. And if that happens, the regulator, in the UK, the ICU, they will find you and they will fine you as this ancient provider that has done. So academics, when they approach us, wanted to use theories because they want to protect the data sources in the center. Now, how do theories accomplish? Theories are close to the environment, where researchers are meant to work safely with sensitive data. In a theory, you will have control of what people access the data, and you have visibility of what they're doing with it. So it's not just some random code drive in the university network. You also have full control of what data goes inside the theory and what data leaves the theory. So you won't have a rogue theory uploading the whole data set into their Gmail accounts. They're really popular right now, theories, many commercial offerings, open source offerings. In health, they're all over the place, and we do use them in the Turing. If you want to work with sensitive data, the Turing will force you to adopt a theory. And we use our own in-house developed software. It's called the Turing dataset. So that's my introduction. Now let's move to the main part of the talk. Let's talk about the promises and the perils. And the first promise is that if you use a theory, your data is meant to be securely stored and accessed only by authorized researchers. And let me tell you how do we deliver this promise in the Turing dataset. What you're seeing here on the slide is a simplified architecture of a theory on the dataset Heaven software. At least in the Turing, we do deploy these theories to the Azure lab. So if you bring a sensitive data set and you want to work in a theory, we will make the data owner to put this data into the storage account called sensitive data. Researchers, they cannot go to the storage account and access the data. If they want to access the data, they need to do it via a workspace, which is a virtual machine. And again, the virtual machine is not open to the world. It doesn't have a public IP. It doesn't have the SSH port open. If a researcher wants to work on the data via the workspace, they need to connect to our remote desktop service called Guacamole. Among many of the advantages that Google provides is control of copy and paste. We can enable disable it. Guacamole is a web application. So researchers are meant to open a browser, go into a URL, and don't need to provide credentials. We do use Microsoft Entra ID. They need a username, they need a password. We have 2FA enabled, they need to provide a phone key. And after that, to all this, they can access the data via the workspace. So how to argue that theories, they do deliver this promise? Data is accessed securely. And we do run some penetration testing at the Turing. And so far, no major issues have been found. But as many things in security, security doesn't come for free. There's always a trade-off. And the trade-off is many times usability. The more secure your solution is, the less user-friendly it becomes. And in the case, oh, sorry, wrong slide. There it is. The less user-friendly it becomes. And in the case of the safe haven, if academics were used to connect via SSH to the workspace, they cannot do it anymore. If they are used to access the internet, they cannot do that, the theory will block it. We only offer workspaces in Linux. If they want to use Mac or Windows, not possible, at least in the Turing. They will need to authenticate once in a while, provide a token, keep their phones close with them, and many times they will need to connect from a VPN. So if you compare all these things when just having the data in your laptop, there's a usability cost to this. Now, how do we mitigate that? Mitigation is like a gradual implementation of the security controls. So you don't need to just go all in. I will put all my controls in place. In the Turing, according to your data set, we assess how sensitive it is. If it's less sensitive, it's tier 1. If it's really, really sensitive, it's tier 3. And according to the sensitivity, we will suggest you to have some control in place. For example, if your data set is tier 1, meaning almost no sensitivity, you can connect to the TRA for an API. So if it's tier 2, you will need to connect from an institutional network, university, your employer, for example. But if it's tier 3, you will need to connect from a set of authorized networks, at the moment, only the Turing network. If you have a tier 1 data set, you will have internet on the TRA. If it's tier 2 or tier 3, internet is blocked. In a tier 1 TRA, you can use your own laptop to connect to the TRA. In the tier 2 as well. But if it's a tier 3, you will need to use a managed device where you do not have admin rights. And in the Turing, we offer the wonderful Chromebooks. Everybody loves them. If it's a tier 1 dataset, you will have copy-paste enabled between your laptop and the TRA. But if it's a tier 2 or tier 3, copy-paste is disabled. Software-wise, in a tier 1, you can install from any package repository because you have the internet at your disposal. If it's tier 2, you can only install packages from either CRAN or PyPI. But in tier 3, you will need to tell us in advance. These are the packages that I want to use, we vet them, and then we allow the installation in the TRA. So those are controls per tier. Now the question becomes like, how do I know which is the right tier for my data set? And for a long, long time, like years actually, we developed this flow chart. You have a set of questions, and according to your answer, you will like end in a bucket, per tier or not. But we find out lately that this approach is really not flexible enough, and many times it's super purpose. So we at the structural research team, we delegated it. So we don't do this assessment anymore. We rely on the project team to tell us which is the tier of the dataset that will be the tier of their TRE. But we don't leave them alone. We provide some guidance, some examples. For example, let's feature in the slide. If your data set has personal data, and sometimes this is not obvious, like it can be an image data set, but there's a picture of a passport. Then it's personal data, go for a higher tier. If you have special category data, race, politics, religion, please go for a higher tier. Or commercially sensitive data, clients, employees, you should go for a higher tier. In contrast, if your data set is already available online, and you'll be surprised, there's plenty of medical data sets just on the internet, on Kaggle or Linode, then probably you can go for a lower tier. Or if it's like a medical data set, but you have rigorously pseudonymized, meaning you remove all the identifying information, then maybe you can go for a lower tier. Now let's make this a bit more concrete, like how do we like customize security controls in a project I am. The project is called CBDNet. It's a project in the health domain. I have research from the Turing, but also some PD arrays based on Sheffield, some PD arrays based on that. So the data come from sensors implanted in people's hearts. It's a clinical trial. So you could argue this is highly sensitive data tier 3. And in a tier 3 TRA, well, first of all, you need to connect from the Turing network or via VPN. You will use the lovely Chromebooks, and you will tell us in advance which package you want to use. Which is a lot to ask, especially for someone based in Sheffield. So our solution was the following. We will keep the raw data into a tier 3 TRA, where our data runners will process the data and they will pseudonymize it. They will remove all identifying information. We'll have a new version of the data set, which we deem is suitable for a tier 2 theory. And the researcher will connect to the tier 2 theory, where they have a bit of an easier life. They can use their own laptops, they can connect to the university network, and they can install whatever they want from IPI or RAR. If you ask our PDRAs, they will still tell us this is not usable, but I would argue it's better than just using a tier 3 PDRA. Now, that's promise one. Let's move to the next promise of regulatory compliance. Like, arguably, if you use a TRE, you will follow all ICO commandments on data protections. Let me tell you that you should follow ICO commandments on data protection, or you will get in trouble. Let me show you a cautionary tale. This American company, 23andMe, they got fined this year 2.3 million pounds. They have a data breach from 2023, and in the data breach, they have information of 150,000 British nationals. Their names got leaked, dates of birth got leaked, pictures of them, race, ethnicity, health information want to be leaked, they leaked. Now, the ICO investigated this and they found many problems in how this company processed data. They didn't have multi-factor authentication. They didn't have secure protocols. They didn't have a system for monitoring what users were doing. They didn't have a detection system. Now, if 23andMe was using a TRA like that in the heaven, they wouldn't be fined by these specific reasons. We do use Microsoft Entra ID, and we require two-factor authentication to be enabled. We do have a secure password protocol, and whatever the researchers they do in the workspace or in the services that we offer to them, the logs, they are stored and they are searchable, so we can have a sense of what they're doing with the data at any time we want. And the workspace, we do have an antivirus, and that's the definition of virus that's uploaded, updated quite often. So, in data protection legislation, there are some bits that are straightforward, but there's a big chunk of them that's ambiguous or unclear. I have done my GDPR training many, many times. I'm sure you guys did that as well. But when we operate a TRE, there are some situations when you do need a legal expert to provide you advice. There's actually the mitigation. Work with your legal expert. You will need them. There's something that we as technologists, we don't know. Let me tell you some of the situations we found while specifically working on CVDNet. Our PI traveled to a country, met another researcher, and suddenly came with a health data set from another country. He wanted to put the data set into the theory. Could we do it or not? Well, I didn't have an answer, but luckily for me, we have Kit Good, our data protection officer, and he provided us with advice. Also, I was required to produce a data governance policy document. I didn't know what that is, what it should contain, what safeguards I should put in this specific piece of documentation. Kit Good, our DPO, helped me draft that document. And also, where humans, accidents happen, we need to know if an accident constitutes a data breach. And if it constitutes a data breach, we need to report it to the ICO. Again, we rely on Kit to tell us if we should tell authorities or not. So that's the advice. Work with your DPO, involve them early, and you will need them. Okay. The third promise of infrastructure management. Like, you adopt TREs, you will not need to deploy or maintain a secure computational environment for your team. The TRE team will do it for you. And that's a really attractive promise, because setting up a computational environment from scratch, it's hard business. You will need to buy software. Even if you use open source software, you will need hardware where to run it. And when you have software and hardware, you will need to hire people to manage it. That can be really costly for a university. As I was mentioning before, the tools they came, it runs on Azure. Azure have many platform as a service offerings, and we just use them. We pay for a service, Azure manages it for us. The Entra ID we're talking about, we don't manage it, Azure manages it for us. We do not have a DBA, database administrator. We just use Azure SQL database, and we even set up a file server. they use Azure files. It's great. So these services, we do not need to manage them. But I can say that, yeah, infrastructure management is delivered. We don't need to manage the infra, but there's a lot of things that we'll need to manage. That is hard to automate. To mention a few examples, PD arrays, they normally use really obscure software with even obscure programming languages. They will need our help to install it into the workspaces. Ingress and egress will need to be monitored. What if the data owner wants to ingress a really sensitive data set into a tier 1? We cannot allow that to happen. Or if a PD array wants to egress the whole data set, again, we need to check and control some things. And TRE runs in production, so production is to be managed. Deploying TREs, tear down TREs, updating versions of new TREs, onboarding users, all these things need to be done. We were naive enough to believing that one person could do it. That person was me, but I quickly realized it's a lot of work for only one engineer. So our mitigation was, do not have a TRE person, but do have a TRE operations. What you're seeing here on the slide is the team for CVD. So myself, I'm in charge of feature development. CVD next one, the TRE to do new things, I'm building them. Camila, she's doing day-to-day user support. She has root access to the workspaces, so she can install stuff, start VMs. Mawish, our data wrangler, she's our data sensitivity expert. So she knows when an ingress is good or when an egress is bad. And finally, we have David. He, from Research Computing Platforms, he's our Azure expert. He manages production for us. This setup worked really well for us. So we all do a little bit of operations, so we have some extra time for doing more interactive things. And this is the final promise. If you use TRE, your data analysis will be scalable. You can use as much storage as you want and as much compute as you want. The TRE will just give it for you. And well, like our TRE runs on Azure, so we can use whatever Azure has to offer to us. And if we talk about workspaces, meaning the VMs, if you go online, you will see that there's a wide variety of VMs with very little CPU, with a lot of them, a little bit of memory, a lot of memory, GPOs, you name it. You can just go there, pick what you want, we will plug it into the TRE, and you can use it to do your science. Let me tell you a bit like how do we like scale compute and storage in the Turing scale. So we expect the data owner to upload the data set using a tool called AC Copy or the UI version Azure Store Explorer because they have some nice feature for uploading large data sets into the cloud. You have parallelism, concurrency, and if for some reason internet went out, you can resume the output. It's a nice tool. The data goes in the storage account, and after it's there, it's immediately visible to all the workspaces, all the VMs. You don't need to copy the data to each workspace, it's just there for you to consume. And your workspace farm is customizable at runtime. If you need more VMs, we can give you more VMs. If you need less, we can just delete them. If you want to change the specs, we can also do that for you. And if you need some fancy algorithm package, whatever, it's on PyPy or Cram, you can use it, or doing data analysis. But as many things in life, and especially in cloud, there's no free lunch. The fancier the tech you use, the more you will pay. To illustrate this point, like before CVD started, I have a chat with the PDRA. He was telling me that there was this workspace in his lab. It had 32 CPUs, 64 gigs of RAM, and nobody used it, so he did his science there. If he wanted to use that machine on the cloud, for 6,000 pounds, it can only be like available in the cloud for 6 months. You can buy the machine for 6,000 pounds, you can have it in your bed, but in the cloud, it will only give you 6 months of usage. And this is a TRE, so it's not only VMs. You have storage, you pay for that. Firewalls are not free. And we provide you with some services. For example, I talked about Guacamole, that costs money. As a repository proxy, we use Nexus, that also costs money. And the virus database mirror running on the cloud, that's also free. So if you do not monitor your costs, they can overrun. So yeah, like the mitigation is just if you're using the clouds, keep an eye on your costs. We do use Azure, and Azure have some, nice reports like the one see here. So you can keep an eye, even on a day-to-day basis, how much money are you spending. And our mantra in the touring, or even in travel, should be like, use only what you need and when you need it. So we're constantly nagging the PDRAs, like, do you really need that fancy VM? Can you use a little one? This service, you didn't use it, maybe we can turn it off. Because of that, you can see that over time, the amount of money we spend on cloud varies. When we need a lot of stuff, we give it to the PDRAs, but after that, we turn it off. And so far, the strategy has worked, and we're still on path. Well, yeah, that's all I have to say today. Just to recap, we talked a bit about TREs, what they are, why do we need them, and I mentioned 4 promises of TREs that they do deliver, some perils, and how do we mitigate these perils in the touring. I want to highlight that a lot of our mitigation strategies, at least in touring, are people-based. For example, implement an operations team or work closely with your DPO. When you talk about security, it's well recognized that's not a technical problem only. There's a people personal dimension to it. But some researchers, when they talk about people, they see it as part of the problem. It's the weakest link of your security system. But at least in the touring, with TRS, people are actually part of the solution. That's all I have to say today. Thank you very much. I'm ready for questions.
Get the slide over questions. See what would be nice. Great. Okay, so Carlos, I guess the top one is, why do you think TREs are being developed in-house area, right? Would it not be more cost effective for different people to share their implementations and have one way to do it?
That's a good point. I think because there's not yet a consensus of what TRE is. Like, if you go into the literature, you will find a lot of different definitions with different features. And many times, at university or groups, they're like, I want this TRE with these features. Nobody offers them to me, so I will just build something.
Is there any, sorry, it's like a follow-up question. Is there a difference between regulatory frameworks? So TREs in different countries require different.
That's right. That's right. Regulation is for.
And next question is, given that Microsoft recently admitted in a French court, they cannot stop or notify US authorities accessing EU data in their cloud. Has this affected your choice of TRE platform? So do you trust Microsoft?
Well, yeah, I gathered all this information, but yeah, we need to assess that we might need to move away from the Azure platform cloud. But I'm just saying, like, the Turing theory is highly tied to Azure. Yeah, we need to leave the cloud, it will be costly for us. But well, if that happens, I think our choice.
Thank you. How difficult, in your opinion, is it to integrate data that's held in different TREs? Is that even possible?
I haven't had any experience with that. Well, at least in the Turing, we only use our own TRE, the safe haven. But from what the safe haven is like, as long as you can put the data in storage account, and we will give you a way of doing that, you can integrate.
But you don't have use cases, for example, where you're integrating with data that's in the Scottish safe haven, which isn't managed by ATI, which lives elsewhere. You haven't done those sort of things.
No, that like recently we have a project called Bridge. You talked about that yesterday. That's trying to integrate safe haven with areas in the supercomputer. So we're working on that. Like, so we do trust the safe haven. How do we know we trust the air supercomputing? And we're working on a regulatory framework for establishing trust between 2 different entities. It's still work in progress.
Cool. We've still got time for maybe a couple more. who holds, this is similar to the Microsoft question, I think, who holds the ultimate responsibility for the data if you use a cloud provider? You know, do Azure guarantee where the data has been hosted and who has access to it as part of your TRE?
That's a question for me. I can tell you what I know. I know that Turing has a contract with Microsoft, and Microsoft has told us that there are only certain regions in the cloud that we can use. We use UK South only.
Okay.
Yeah, so I think that they'll need to be contract based. To predict you.
Cool. I think maybe time for one more, and then we'll give people a chance to switch around if they go into other sessions. What's the process of pre-approving packages for tier 3? Is that manual curation? How do you handle upgrades? Can you say something about how that process works?
It's a manual process. So the tier will tell us, I'm going to use pandas, I'm going to use NumPy, and we go on an assessment. For the author of this library, the version recognized, widely used. If that's the case, we will just enable them in the theory. If it's not, we probably ask more questions, but I haven't found anything yet like, oh yeah, this, you cannot use it. Maybe once, like, they asked for a VS Code plugin that was made for some random developer. So if there's a Microsoft official one, maybe use that.
How do you manage the dependency tree there, right? So you said pandas, but pandas depends on right. So you have to go all the way down the chain, essentially.
Yes. That's also, right now it's manual. We can do it better, but yeah, we explore the dependency tree. You tell us we need pandas, we do traverse the dependency tree, and we have all.
Great. Can we thank Carlos again?